Okay, so the primary topic for today was kind of a, I guess we'll call it a reset, to help you understand kind of where we're at in the Java community today. We've all lost, 2 years of our life, so this is just, we felt this might be a good opportunity to kind of reset and give you an understanding of where things are in the Java ecosystem. And by all means, this is going to be a very interactive discussion. So if there's something that that you're seeing, something that you've experienced over the last 2 years, some new feature or something that really comes to mind, and I don't cover it here this evening, please feel free to chime in and add. So the agenda will be like this. We'll just we'll start off with some statistics just to make you feel better about Java. I just saw another article yesterday. Is Java dead? I mean, another one. Geez, okay. Anyway, so we'll talk about statistics, and then we'll talk about some kind of foundational things that you may be aware of or maybe you're not aware of. But this allows us to kind of get everyone at the same plane or same level. So we'll talk about the release cadence, the JET process, JDK enhancement proposal. We'll talk a little bit about the features between LTS and using an acronym there, long-term support. We'll talk about that also. Questions that we often get around what's the difference between OpenJDK and the Oracle JDK, for example. Then we'll talk a little bit about what's new in 18, the big 4 projects. I'll talk a little bit more about that, and then we'll wrap up with any questions. Okay. That sounds good. We'll dig in. So just some stats. Again, I mentioned the Is Java Dead article again, and there seems to be one every 6 months. And the fact of the matter is, and this has been my experience, certainly, I've been back at Oracle for about a year and a half. And I can tell you, the activity hasn't been any more rampant, right, over the last 18 months than I've ever seen. And I just a little history. I was on the Java software team at Sun back in the day for 12 years. And things were very active back then, as you might imagine. But just recently, I mean, the uptick in interest around Java, and you'll see why, hopefully, with some of the updates and features that have been introduced here over the last few years. These, I'm not going to go over each one of these, but hopefully these make you feel better as a Java developer and kind of reaffirm that no, Java's not dead. In fact, it's probably as strong due to the community and how we're approaching releases now. So again, there you have it. So let's talk a little bit again about some foundational things. And some, again, this might be a review for some of you, but the release cadence for Java has changed over the last few years. Releases used to be kind of haphazard and would happen, sometimes it would be years before there would be updates for Java. So the community has taken kind of a different approach to how Java is released. And it's now in a 6-month cadence, so time-bound cadence. So every 6 months, in March and September, there are new releases of Java, new version releases of Java. There'll be patches along the way, but in between those, every 6 months, there's what's defined as a non-LTS release. So LTS stands for long-term support. So the difference between the two is the non-LTS, every 6 months, after that 6-month period is over. So when we go, for example, from 15 to 16, Java 15 to 16, after 16 is released, there's no longer any updates or patches that are released for that update. And there's no overlapping patches. So as you might imagine, this isn't, those are the versions that you probably don't want to target for production because they're not going to be supported past 6 months, even if you can get commercial support for them. Now, alternatively, there's this notion of long-term support releases. That's Java. Today it's Java 8, Java 11, and Java 17. Those are the LTS releases, the long-term support releases. Those we would recommend for production because they're supported for long periods of time, most often 6 years or longer. So you can, if you're in an enterprise organization that can't be quite as agile with updates for your Java runtimes, etc., the long-term support releases are for you because they give you an opportunity to have them in place for a long time before you're either forced to upgrade or need to upgrade.
Is there a limit to how many long-term support?
So the question is there any limit to how many LTS releases there are? There is not. Yeah. It's an option. At some point, though, support is going to be discontinued, right? If you're getting support for it, meaning that you won't get patches or critical security updates, etc. That's the case with Java 7, which is actually July 22, I think. July of this year, there's going to be no more updates and patches. So at some point, you're going to have to move, and that's not an LTS release, but you know, that would be the case with LTS releases also. The reason why Java 8 is still around is a lot of organizations had it in production and still do today. So that's going to be supported by most organizations, you know, like Oracle and Red Hat, IBM, et cetera, to 2030. So you still have 8 more years. But, you know, you'll see here, and I've got a timeline. That's an 8-year-old technology right now, Java 8. It's hard to believe, but it's 8 years old. So, you know, as developers or as those that have an interest in your Java ecosystem, you should be pushing your organizations to move to a more recent release. And we'll talk about that here in a moment.
Isn't the next LTS a little bit quicker?
It is. It's 2 years. Yeah. So, so the question is the next one going to be 3 years? No, it's actually going to be 2 years. So Java 21 is actually targeted for the next LTS. And here, well, before I get to that, let me stop and kind of explain the reason why the community has opted to the 6-month cadence as opposed to what was done previously. So you can see on the left-hand side of the screen, you've got, you know, some of the older versions of Java over there. And the numbers on the left are features that were added to those particular releases. So you can see we added 56 and 91 respectively to JDK 9.8. That's a lot of features improvements to maintain. And that's the reason why there was such a, you know, in this case, a 3-year period between releases, because when you're adding that many new features, it takes some time to obviously engineer. So with the 6-month cadence, what that allows is we can add a smaller amount of features and then be able to adhere to that 6-month cadence. So you'll notice that, you know, over the releases here over the last, you know, few years, well, there's some that are 17, which is quite a few, but, you know, most of them are either, you know, low teens or even single digits for that matter. So it's a much more manageable approach to releasing new features. So that's why this is kind of visually why we've kind of moved to a 6-month cadence. Hopefully that makes sense. So this is kind of the timeline past and somewhat into the future. Again, I mentioned Java 8 came out in 2014, so it's 8 years old. Even Java 11, for that matter, I mean, is, you know, it's 4 years old now, so it's aging already. Also, we're currently at Java 18 as the newest release, came out in March of 22, and as Dan just mentioned, the next LTS version is targeted for September of next year, which will be Java 21. Okay. And then, if you've got support, you can go to whatever vendor you have that provide support, and you can see when they're going to be supported or not supported moving forward. But you can see we're kind of following this March, September release cadence every year. Okay. Now, it's always subject to change. Something could happen, but this has been pretty solid here over the past few years. So any questions around the release cadence and any of the timelines? Yeah. Yeah, so the question is, are JVM versions the same as Java versions, right? Yeah, so yeah. I guess people tend to use the terms interchangeably. You know, you'll hear JDK, JRE, you'll hear runtime, you'll hear Java, you'll hear JDK. Yeah, all the versions, they all coincide. Yeah, all the numbers. There are, I shouldn't say that. If you do a Java minus version, it'll show you what version you have of Java. But depending on if you've got open JDK versions, it's also going to have these other kind of cryptic numbers associated with like 22.3. And those numbers are associated with the year and then the month of the release. So if you see some odd numbers there, you know, with your Java dash version, output of your Java dash version, that's why you see those numbers. But typically you'll see like a, you know, 17.0.3 or something of that nature. But with OpenJDK, you'll see some other numbers too. Okay, features and enhancements. Now, I'm not going to go through each one of these, but this is here to illustrate that if you're still sitting at Java 8 or a Java 11 for that matter, these are all the updates and features that you've missed over the last 5, 6, 7 releases of Java, which is pretty significant. Not included in this list is just the performance and the enhancements we've made to garbage collection over those years too. There's 2,000 plus, I think there's over 2,000 plus improvements that we've made just to the garbage collectors in this time period. So you're missing out on performance and you're missing out on a lot of the features. So again, this is meant to be an eye chart just because we wanted to kind of demonstrate how many features and new functionality have been added just in between the LTS releases between 11 and 17. So quite a list of features and updates. At a future session, we're talking about Java migration. So I'm sure there's questions in your head. Well, yeah, but how do I get from 8 to 17, for example? So that'd be a good session to talk about those questions. But there are just in a nutshell, there are tools and blueprints and best practices to help you migrate from 8 to more modern versions. I would recommend skipping 11 and going right to 17 for a lot of reasons. A lot has to do around performance, but some has to do around licensing, and I'll talk about that here in a moment also. Sure.
I'm just curious. I don't really know the terminology there. What are the previews of each?
Great question. So the question is, what is preview incubator? I'm going to cover that here in a moment. Yeah, good question. So all those features and new additions to the Java ecosystem are done through a process called the JDK enhancement proposals, or JEPs, as we like to call them. Excuse me. So this is where we kind of collect and kind of sort and review all the features or proposals for enhancements to the JDK. And the result of that is essentially what you saw on the previous page. It's kind of a roadmap of features that we add, and by we, the community, adds to the JDK. So it's intentional, and it kind of results in this ongoing roadmap. The roadmap is rather extensive, and it's intended to extend to 3 years plus to be able to allow for time for those features to be engineered into the JDK. We talked about the 6-month cadence, so we've got kind of a 3-year feature schedule that we're trying to follow the community to get all these features and proposals added to the JDK. And then there's kind of an explanation around what exactly is an enhancement and what qualifies as an enhancement. and you can see kind of the prerequisites, if you will. It requires two or more weeks of effort. It's either a significant change or the process or infrastructure that's supported, or it's in high demand by you as developers or customers that we might have. I don't have the list because the list is really extensive, and you'll have access to these slides, but there's a rather extensive list of all the JET proposals that are in place today. A lot of them are in motion, as you might imagine. Some of them are still on the list to be worked on or assigned. But this is the process that the community follows to add new features.
Scott,
Mhm.
who maintains how are
So the question is, how are the proposals deemed worthwhile, right? Yeah, right.
Worthy, whatever.
Yeah, so that's a great question. And that's kind of changed over the years too, about how the features are evaluated. You know, obviously there's a community behind, right? There's geez, I don't even know how many companies there are now. I don't know, Dan, do you guys even know? Yeah. There's a boatload of companies behind the community, and they all have representatives. And the features are kind of evaluated not only by the community, by popularity, but then, you know, this, what's the word? My brain is kind of, the committee, thank you. Yeah, let's knock this 3 times. The committee evaluates and kind of ultimately makes the decision or kind of drives the features in a direction. But go ahead.
Does Oracle stand back?
Well,
I mean, they might have representatives.
yeah, we have, yeah. And so what will happen is a company will have a representative, and that representative will kind of, you know, do the voting and all that kind of stuff, right? So, and companies can have, you know, you can have individuals that are part of lots of different active JEPs that are in process. You know, there might be subject matter experts that are kind of leading some of the features and functionality, right? And they have representatives on the team. So it's all done in the open, though, right? Everything's done very much in the open, and it's really based on those 3 criteria to see at the bottom. As long as it fits those criteria, then I haven't come across very many that have been, you know, kind of pushed to the side without really evaluating whether it's worth it. It is. Oh, it's, yeah. Yeah.
Nothing ever happened. And that's what happened.
Yes.
5 years.
So if you've been around Java long enough, you remember the Java community process and how that worked and how well, I should say how it didn't work. Yeah. So this is a much more efficient process, and it's paid off. And hopefully you've seen that with a lot of the features that you wanted to see as part of it. So what's a feature? You know, we just talked about features, and features can fall into a few different categories. They can be a language feature, right? That's part of the actual specification for the language. It could be a API feature, right? And there's some examples here, java.lang.object, for example. It could be a JDK API feature, which is JDK specific, such as tools like Flight Recorder, if you're familiar with JDK Flight Recorder. It could be a tool like JShell or JLink, if you're familiar with those tools, or it could be specific to the hotspot JVM itself. So something that's part of the OpenJDK implementation of the JVM itself. So those are typically the categories that all these features fall into. And then earlier the question as well, so what is incubating experimental? So hopefully this explains it. There are 3 different, well, there's several categories, but these are the 3 primary. One of them is a preview, right, which might be, the specification might be finalized, but it's not completely finished, right? It's not actually part, you can use it. It's part of the distribution that you might receive or download. You're welcome to use it and provide feedback, but there's still some things that need to be tweaked with it. Experimental is mainly for new features, specifically to the JVM, the hotspot JVM. And then incubator or incubating modules, they have potential to be new APIs or part of the JDK or the tools. So back here in that list, you saw some that are in the incubator stage. They can actually go to preview 2, for example. So there's different stages of these categories. They go preview 1, preview 2 as they kind of mature through the engineering process. So you might see different versions of these categories, but nonetheless, this is kind of in general what that means. Okay.
Scott, is there a linear? Are these things linear? Or is it based this category when you're ready to move to the next phase, you might go into?
Yeah, so the question is it linear, these phases? I'm just trying to think back. I think in general, yes. I'm trying to think if there's any exceptions to it, but I think, yeah.
Yeah, because preview sounds like it's like, just by the description, it's like it's gone through incubation or experiment.
Yeah, yeah. I kind of I probably should have had them in the order of how they're implemented. Yeah, so incubating would be first, experimental, and then preview. Yeah, sorry.
Preview doesn't even mean just preview for one, because I know like records went through like 3 different
Right.
previews before they got it right.
Yeah.
So it's a chance for them to go, okay, here's what we thought we do. You guys told us we're wrong, we're gonna change it.
Yes.
So I went through like 3 iterations.
Right. You'll see preview 1, 2, 3, like you said. Yeah.
From a sort of a user point of view, program point of view, does it mean that they're available, but you better not count on it because they might cheat? Or what does functional mean?
Yeah, typically they're really there. I mean, you could use them, but as Dan suggested, there could be some subtle changes to it. Typically, it will be subtle. In some cases, there have been some major changes, but typically it's going to be subtle.
And you have to put a preview flag on the
Right. Yeah, there's a flag, right. There's a flag you can pass. Yeah. It says enable experimental thing. Right. You see.
So you're kind of forced to
Yeah.
admit that you're doing it. Just start using
Okay, so any questions around kind of the process of adding new features? Trust me, it's improved 1,000% over the years. Yeah. Okay, so now we'll talk a little bit about the Open JDK and differences. This is a question I get quite often, and it might be in the back of your mind too. What's the difference between all these different versions? So the Open JDK was launched way back. The project was launched back in 2006. Of course, Java came on the scene in '95, but the Open JDK project, when things were open source, was actually in 2006. My son, I was still there at the time. And then some new bylaws were ratified in October of 2011. So it was changed. The approach was changed a little bit. License was changed a little bit around Open JDK. But essentially, since Java 10, the reference implementation for the Open JDK is being managed by what's called the JDK project. And that project defines everything that goes on within the Open JDK community. Structure and approach and everything that's associated with the release of Open JDK. And there's groups and projects, subgroups and projects that are associated with it also. And there's some links there where you can check it out. But bottom line, Open JDK is the free and open source implementation of Java SE. Now, comparing the Open JDK and Oracle JDK, one thing that I want to make very clear is they're both based on the same Java SE specification. So they're built from the ground up with the same technology. So technically, there's no difference between Open JDK and Oracle JDK. Now, there's some optimizations that Oracle puts into to their JDK, but technically, there's nothing different with the two. In fact, back in 2017, Oracle, I was still Red Hat at that time, Oracle open sourced some of the remaining tools that were part of the JDK. So if you're familiar with JDK Flight Recorder and Mission Control, those were all open sourced so that everything in Open JDK matched with Oracle JDK. So essentially, they're interchangeable. Right? You can swap out one for the other, and you can expect not to encounter any issues with libraries or anything. Right? So they're 100% the same since Java 11. So Java 11 forward, there's no difference. Prior to that, there were subtleties around JavaFX and some other things that were included, fonts and some other crazy things that were part of the JDK. But as of 11, they're identical, functionally interchangeable. Now, there are some differences today around the Oracle JDK and Open JDK functionally. Right? Technically, they're saying functionally, there's some other features that are shipped part of the Oracle JDK, and that includes AMC, which is Advanced Management Console, Java Management System, and Growl VM, which is a team on it. And those are shipped part of a commercial offering. But technically, just be aware there's nothing different between the two. Okay. Any questions on that? Okay. From a license perspective, Oracle JDK, Open JDK, I should say. So Oracle provides an Open JDK version and a Oracle JDK version. Right? The Oracle JDK is a commercial version. Okay? Open JDK, of course, is open source version. So it's it's released under GPL v2 with class path exception. I'll talk about JDK 17 here in a moment, but the license has changed with 17, and I'll talk about that here in detail in a moment. Again, there are some versions that still have some support behind them or require support from an Oracle perspective, so they fall under a different license, which is termed the OTN license. But essentially, that's kind of the gambit here of licensing. So Open JDK is a GPL v2. Oracle Open JDK is also GPL v2. Oracle JDK falls under a different licensing term called Oracle No Fee Terms and Conditions. So beginning with Oracle 17, which just came out last September, Oracle made Oracle JDK available for free. So prior to Oracle JDK 17, you had to pay a subscription if you wanted support or updates, etc. Moving forward with Java 17, that's no longer a requirement. So you'll get all the quarterly security updates, patches, etc. And that's whether you're using it for commercial use or even in production use. And this is due to this new license, which is a no fee terms and conditions license, which allows, it's free for all users, even in production. And you can redistribute it as long as you're not charging something for it. And the click-through is really easy now, right? You can just download. In fact, we're implementing some new stuff now that, in fact, I need to talk to you about this, Tam, about tokens to be able to download. So the process for downloading is a lot easier than it used to be. And then we'll provide free releases and updates for 1 full year after the LTS. So now that you know what LTS means, we'll provide updates for 1 year after the next LTS. So after, in this case, Java 21. Anything prior to 17 is not affected. So you'd still need a subscription if you want support and updates, etc. Okay. Any questions on that? So this is a pretty significant change in the licensing for Oracle.
So is that a return basically to the old kind of situation where
Yeah,
you just downloaded Oracle?
it is a return.
and you ran it?
Yeah, the question is this kind of a return to the olden days? And yes, it is. Yeah. Yeah, so it's very, it's a nice change. And so going back to my comment earlier about why I would recommend moving from 8 to 17, take the big jump. Well, this is one of the reasons, right? You know, there's no financial burden from a licensing perspective. Of course, there's burden for moving from 8 to 17, but from a licensing perspective, there's nothing that would preclude you from moving to 17. Why? Good question. I think it just had to do with it was feedback from the community is really what it came down to. And I think what we're, and going back to the fact that, 7's come to end of life, 8 is, granted, it's going to be supported until 30, but I think there was some kind of writing on the wall as far as we want customers to move to modern technology, right? We understand 8's there and we'll gladly take your subscription for it, but we want you to move to a modern technology. It's easier for us to support. It's easier for Red Hat and IBM to support because it's more of a modern technology. So I think there's a lot of different factors that kind of helped with this decision around licensing.
A lot of people are just downloading it anyway.
That happens, absolutely. Regardless, doesn't matter if you're, if you've got an Oracle distribution or someone else's, and we'll talk about that here in a moment. Technically, there's nothing preventing you from doing that. Legally, if you were to get audited, then you'd have to pay, back licensing fees, right? So again, if you don't want to mess with all that, this is what you should be considering, right? Moving to 17. So this is with 17 forward, by the way. So 18 was just released last month or month before. So this will be the case moving forward with all of them. Okay. Yes.
That license is most of the other JDKs or JDKs you can get are all under the GPL2.
That's right.
Class path exception.
Right.
Does the Oracle license have like attribution stuff like that? Where you make a change, you have to source code back, or is it more of your traditional style license?
Yeah. So the question is, with the new Oracle and NFTC, as we call it, are you still expected, for example, to if you make any modifications or improvements, or are you obligated to contribute those back to the community? Is that, yes, that's still the case. It's just that we're not, yeah, it's still, I'll just leave it at that. It's still the case. Yeah. And I don't have this here just because I work at Oracle, right? I just wanted you to kind of understand how the licensing things are, just so you know moving forward. Yep, question?
Just to clarify that 1 year, after JDK 21 comes out, 1 year after that, does JDK 17 move into the fee-based model?
It does. Yes. Yep. Yep. But hopefully, maybe you're moving to the LTS version by then, right? And then you're still good, right? You can, if you're willing to make the commitment to update, even at each LTS, then you're going to benefit from it. Any other questions? Okay. So I talked about the other options, right? There are tons of them. I mean, I don't even know some of these, to be quite frank. Right? I mean, some of them obviously are Adoptium is the old JDK. obviously Amazon Corretto is big, Azul's a major player in the space, but there's a lot of them. Obviously Red Hat, Microsoft has an open JDK now. So there are a lot of players in the space. Yeah, again, some of these I don't even know. I just found a list somewhere and thought it might be interesting to see there's just not Oracle and Red Hat and Amazon. There's lots of other players in the space. So yeah, so Oracle, Oracle had JRocket in its portfolio for a long time, and they took some of that technology and kind of blended it into the JDK. What's that?
I think mission control.
It did, yeah. Mission control, a JDK flight recorder, they were all part of that JRocket, yeah. Now it's all open source and part of the part of OpenJDK also. Okay, so what's new with JDK 18? So again, 9 JEPs, you know what JEPs are now. 9 JEPs were delivered with JDK 18 with last month. And again, they fall under different, the different feature categories that we talked about a little bit earlier. With tools, updates, improvements. You'll see that there's some in preview 1 and incubator 2. You'll see some are in second preview and second and even third, as we talked about a little bit earlier. So these are still being developed, but some improvements were already added using kind of standardizing by using UTF-8 as a default. There's also a simple web server that's been added. It's kind of cool. Just do JWeb server. You can assign a port and even a directory. So you've got a cool little web server now that you can use in your Java environment to quickly fire up. There's code snippets, something to help with style and consistency around coding. That can be used in IntelliJ and other IDEs, for example. Some have you'll notice that some things have been deprecated also or removed. Finalization, for example, is targeted for removal. Anyway, there's a blog here. I'm not going to go through each one of these, but there's a blog there that kind of highlights. There's actually a video if you're interested in what's going on with 18. I just thought I'd kind of review quickly what's going on in that space also. Okay, and then there's what people kind of affectionately call the 4 big projects. Well, actually 5, I guess, think about it. And these are things that, these are projects that have gotten a lot of notoriety and exposure, I guess, if you will. And I'm going to walk through each one of these. But the idea here is that, there's still a lot of innovation that's going on in the JDK environment. And these are some of the major projects that are going on. And I'll cover each one in a little bit of detail here in a moment. But just in a nutshell, Amber, Loom, Panama, Valhalla, and I added the ZGC, the Z garbage collector, just because it's kind of cool and interesting and has been added to recent versions of the JDK. So Project Amber. Project Amber is what we're kind of following now with the 6-month release cadence. In a nutshell, it's just about adding, productivity-oriented features to the JDK. Smaller ones, right? Not typically major features, just smaller things that need to be added to the JDK. In fact, we've used that, as I just mentioned, to kind of jumpstart or bootstrap some of the features that have been added to those versions that you saw a little bit earlier. And there's some examples of some previous Amber projects. One thing to understand is that Project Amber is kind of an ongoing project. So there's no end to it like, the Lambda project or something else, right? Where the features have been developed and they've been added. Project Amber is kind of an umbrella for all the features as they continue to be added to the JDK. So it's an ongoing project. There's no stop to this project as far as I know, right? This this is what we're going to use and have used to implement new features. So if you hear Project Amber, just think of it as kind of this ongoing process that we're following to, or guideline that we're following to introduce new features into the JDK. Project Loom is a really interesting one. And this is about adding high throughput and lightweight concurrency to your applications. Today, well, let's see, Loom was introduced in 18, I believe. It's available today in 18. Previously, before Loom, you would have threads mapped directly to the threads in the OS, and that obviously would place a limitation on the scalability of your applications when you have kind of that one-to-one ratio for threads to threads with the OS. So what Loom introduces is virtual threads or virtual threading through this notion of fibers. So you can actually abstract the number of threads from the underlying OS. So now you can have tens of thousands, if not millions, based on your hardware. If you've run into thread problems previously, I mean, there's only so many threads that can be supported on an operating system. When you run out of threads, well, there's a problem. So Loom introduces virtual threading concept, and this is something that has been in demand for a long time, as you might imagine, to get the scalability and the performance of Java applications kind of through the roof. And especially when you think about how Java applications are deployed today, just the models behind virtualization and how the applications are deployed, it made sense for us to kind of apply the community to apply that concept to threads also. So watch out for this one. This is something that was a really high demand feature. It's been worked on for years and years. Dan made a point earlier about how we kind of approach it and then had to take a step back and re-engineer how we approached it, and now it's at the point where it's available now in JDK 18. Project Panama is all about interconnecting the JVM with native code. So if you work with JNI at all, you know that it can be rather difficult. It's an understatement. And so Panama is looking to kind of simplify that process of being able to connect your applications to with the Java native interface. Okay. Valhalla is more towards the way we work with data types, especially data types that use data access, right? For data items. In fact, the name Val, use Val in the language. That's kind of how the name came up, Valhalla. So this is so Valhalla's, I like this line, right? To heal a rift between primitives and objects, get them to work together a lot better. So there's a new data type that's being introduced that helps you access or program objects, I should say, but access them like primitives. And there's, again, this is kind of still in motion, very much in motion. So this is one of those projects that still has some engineering work to be completed. But there's different proposed capabilities around the objects, around the primitives, and kind of the unification of those within this type of new data type.
What category is this?
I believe this would fall under the language. This is language API, Java language. Yes.
Just is this something that a programmer would specify that is a value object, or is it something that is under the covers where it recognizes this thing as this object?
The goal is to have it recognized.
So that you don't have to, like, you're not programming it so much. It will take care of it if you have the right. I mean, obviously, we'll be aware.
Right. There is going to be a new approach, right? I mean, it is a different data type, and it will require relearning of how you approach it. But a lot of the lot of the plumbing underneath is taken care of for you. So I've only seen a few examples, real life examples of this, because it's still kind of at an early stage, so to speak. But again, the goal is to make it a lot transparent, I guess is the word I'm looking for.
And I will say, I'll add to that, the JEPs, if you go into some of these JEPs, like I read the Louis JEP, it reads like a book. There's so much information in these JEPs. So if anything like this interests you, check out the JEP because there's a whole bunch of info.
Yeah.
I'm hoping for the version that is the excerpt of the book.
Yeah. Yeah, that's probably the first 3 paragraphs.
Yeah.
There's a whole bunch more.
Yeah, it quickly escalates
Yeah.
into some very technical. Yeah, Scott. Yeah.
Is the whole essence of this kind of like create applicants quicker, disturb quicker, garbage collecting quicker, maybe create like maybe a file before you start something up?
That's one approach that's being considered. Yeah. Mhm.
I'm just curious, because like in the security part,
Yeah.
right, if you have primitives, typically always take like passwords from the primitives,
Right.
so they don't dump.
They don't dump. Right.
So
This is
I'm
yeah.
curious about
Yeah.
how that impacts.
And then the last of the big 4 or 5 is a new garbage collector called the Z garbage collector, which is a low latency garbage collector. And I've kind of fooled with this with some applications, and the performance is quite amazing, actually. You can use, and it's versatile, so you can use it with applications that require low latency, or if you're using you're using very large heaps, even into the terabytes, which makes this a really versatile garbage collector. And there's a lot more detail about this that I'm happy to geek out with you about. I've worked with garbage collectors a lot over the years, and this is very intriguing. Again, this is another one that's been worked on for many years. It's now included in JDK 17 moving forward.
Do you guys have like performance stats on some of the stuff? Because I've heard that, for the longest time, any lower level language like C or C++ is going to be much faster. I've heard that's not the case. It depends on what you're doing, obviously.
Yeah.
It's not always the case now where like you need to be the fastest, you have to reach C.
So great question. So, or comment too. So over the years, and I mentioned, the 2,000 plus improvements we've made around garbage collection in general. And you do have options now. I think the default collector now is G1 GC, the G1 garbage collector, which is a really versatile garbage collector. It's great for throughput, and it's great for managing, memory management, etc. So that's typically what most people will use because it's a very balanced garbage collector. But to your point, depending on your workload, you can, the serial connector might work for you, or if you've got serverless applications, there's actually now a no-op garbage collector, right? That doesn't do anything. So there's options for you that you could tailor based on your your goals of your application, whether it be throughput or whether it be management or whether it be working with a serverless application that doesn't need to GC. So you've got lots of different options, and ZGC is kind of I see that kind of taking it might be the next G1, right, taking the place of the G1 collector. As it continues to mature. Okay, ended a little bit earlier. If you want access to the slides, you can just take a nice little snapshot of that. We'll post them to the meetup site also. So any questions? Any other questions? Any questions in general? Right? Doesn't matter what it is. We can between us we can answer any questions. Yeah.
Not to be obnoxious, but I just want to follow on with Dana. So I want to say, so what is that? Like, I hear all that about the garbage collection. When you do the stats, how close is Java using these optimized things to writing C?
Yeah. So.
Or is it just too big?
No, well, there's a lot of it depends. I was just debating whether I should talk about GraalVM and just native image in general. So the performance of Java applications obviously has changed significantly over the years, right? I just spoke of serverless, and you never would have considered Java for a serverless application years ago. But it's changed, and it's changed because of the optimizations that have been included in both the C1 and the C2 garbage collector, right? So to address some of the other concerns, I guess, around performance and startup time, this notion of ahead of time compilation was introduced, where you can actually take your Java code and compile it into native executables, right? Without the need to have a JVM or distributed JRE or whatever the case may be. So that's kind of taken, there's a lot of momentum behind it. And there's an open source project called GraalVM. And GraalVM addresses two performance, I guess, concerns. Number one, the C2 compiler has been changed in GraalVM to a highly optimized JIT C2 compiler. So you get extremely amazing JIT performance now, just because of this new optimized compiler. So if you're running traditional applications that, you know, from run for long periods of time, they optimize just like they would with prior to GraalVM, but this new optimized C2 compiler takes it to another level. All right, so there's that. And then the other aspect of GraalVM is the ahead of time compilation. So you can actually take, you know, a Spring Boot application. There's a project, and we'll talk about this probably in the frameworks next month. But there's a Spring Native project where you can, you know, compile your Spring Boot application using some of these native libraries into a native executable that starts up lightning fast. I mean, the comparisons are just amazing. I encourage you to look into it. But you know, you go from 3, 4, 5, 8, 10 seconds startup time with a traditional JIT to, you know, 20 milliseconds to start up. So the startup times are lightning fast, and that's because, you know, obviously you're executing a native executable, right? Now there's some, you know, there's some things that you need to consider, right, around this. You know, reflection is a concern because it doesn't work. I mean, think about reflection in a typical Java application. Now you're compiling something into a native image that can't change, right? So there's things that you need to weigh in terms of your application, right?
Honestly, will start up and end very quickly. Because you want to be
Exactly. Serverless, right? Perfect. Functions, right?
And
Anything.
if you do those, then that long startup time is just
Right.
And the memory footprint.
And the memory footprint is, I mean, you're drastically reducing the memory footprint too. So the resources that you use. Think about deploying in Amazon Web Services, right? You're always concerned about how many resources you're using, etc. So reduced memory, remove CPU, you get greater density in the amount of applications you can support. So there's you know, it's something that, you know, it's an option for you to consider. That's right.
There are cases where
Right. Yeah. Mm-hmm.
Yeah, another big use case is you're a company running like a bunch of microservices. We have clients. You have 20 microservices. You know, 2 years ago, you were going to run that on your laptop. You deploy this to another environment. Now you can build backs, containerize these applications. Because they're so small and taking up so much less memory, you could run those in a container like a K cluster right on your laptop. Like 2 years ago.
Yeah, it's not uncommon for me to be running, you know, a small Kubernetes cluster on my laptop, running, you know, 100 instances of some native image application. It's crazy. Yeah. So anyway, I probably didn't answer your question directly, but
that was pretty good.
Yeah.
That's what I was.
But we do have-
that ability, the ability to create those native executables.
Yeah.
Again, don't want to use it for.
Right.
But
It is compelling.
Resolves a lot of the problems we have when I decide what to do.
Yeah. Right. Right. There's trade-offs and things to consider, like you talked about, but yes. Yeah, compile times, yeah. We're working on that, but
Back to
yeah,
the Good old Java days.
yeah.
Times were breaks.
But there are benchmarks, by the way, just to get back to your original question, there are a bunch of benchmarks. There's one called Renaissance that we reference quite often. Renaissance.org, I think it is. And there's benchmarks for, I think going Java 11 and forward, that benchmark a lot of different attributes based on different workloads. So if you're looking to get an idea of performance, even different languages, Scala and Java, etc., right? Anything that runs on the JVM, those are all part of the benchmarks too. So, but in general, we've seen a really dramatic again, I hate to keep going back to 17, but that's a reason why you should consider 17 because the performance is really, really good. Yes.
You mentioned that two of the big selling points on this value for like improved JIT, so ahead of time compilation.
Right.
To me, it sounds like those are like you only get one or the other, right? Or does the ahead of time compilation include the JIT?
So great question. So the question was, I talked about JIT and I talked about ahead of time compilation. They're two different approaches. So if you've got existing legacy applications today that either you don't want to put in the effort or time or resources to modernize them, so to speak, this is a really simple approach to getting better performance. You essentially just swap out the Java_home, point it to GraalVM instead, and hopefully you're going to realize some performance improvements without changing any of your code, modifying any of your code. So low-hanging fruit, so to speak. So that's one approach. You can use it for new applications, or of course, right? But that's just one use case. And then the other one is, right, if it makes sense, if you're gone down the microservices path, you're looking at Quarkus or Spring Boot or Micronaut, and you've kind of adopted that methodology for creating your applications, then native image might be something you want to consider, because you're kind of in that that mindset is there already. It's just a question of the effort that it might take to migrate your application over, because there is a level of effort. Greenfield applications, no problem. If you're using Spring Native, you're in Quarkus, Micronaut, they're all designed to run on GraalVM, right? So it's a natural fit for those types of services. So it's dependent on your use case, I guess, is the bottom line. Yep.
Back to the topic we still get.
Sure can.
Bridge between them. Like, is there something down the road where you might come in and say, well, here's how, like somebody pick up a topic and say, here's where you want to migrate something.
Yeah, and we have Java 8 to 17 migration, but I see what you're saying. Yeah.
Like in the Java and DevOps.
Yeah.
Or even in the security one, you could do it. Framework one, you could probably pull in like what.
Yeah, I think we could talk a lot about that. Yeah, we could definitely.
If anybody's looking for, like,
Yeah.
if somebody's already, and they're starting to think about things, maybe
Yeah.
work some of that in there. Like, because the big question I ask is, why are so many people on old versions?
Yeah.
Right? And what's preventing them from moving to newer versions, right? So do you just throw the baby out with the bathwater and start over?
Well,
Or are there techniques to migrate
yeah.
from 9 to 17, and then what pieces do you look at an application to like allow, say, okay, we're gonna redo this, but other things just gonna get the benefit.
Yeah. Number one, we can certainly address that in the Java frameworks discussion. Most definitely, we can talk about. Maybe that'll be one of the questions. How do you migrate your application? What are the considerations? There are some blueprints that kind of guide you through it, especially from just the Java 8 to 17. There's some guidelines there. There are also some tools that are actually built into the Java, the JDK itself. If you've heard of JDEPs, for example, you could actually see what dependencies your applications have. That'll kind of help you gauge the level of effort of migrating an application from 8 to 17. There are a lot of considerations. There are, and that I think people are just, they're scared of that, right?
Right.
They can't, this is my production application. I can't mess with it. But, there's like, all right, but we can make your application perform a lot better and you can use a lot less resources if you kind of move. So it's organization to organization is what I've seen. Those that have kind of adopted micro resources, a lot of them are starting, greenfield applications, right? This is what, if you're building a new application moving forward, this is the guidelines that you follow to create those applications. So, and there's no company that does one or the other. They're all doing in all of that. We're staying put, we're migrating, we're looking at microservices frameworks. And then there's some of our, what's Docker, right? So it's all over the place. Seriously. Yeah. Yeah, we've heard of this Kubernetes thing. What do you think? So I don't know if that answers your question, but I know we can address some of it certainly next week, next month in the frameworks. But I'll jot that down as a, as something that we can.
Look at like where the language went,
Mhm.
then they go back and look at reality.
Yeah,
Where apps are, it's like it keeps widening.
it does. No question about it.
Like, there's got to be something better that maybe people start aware of where it's at and help migrate or
Yeah.
protect or-
And I think that's where you see some of the is Java dead come from, right? They're the people that are using Java 8, or that's all they think of. They haven't seen what's happened here in the last.
But even
3
that
years.
article, I saw it the same way.
Yeah.
It was one paragraph, but it's not that. Like,
Right.
It was just, it was.
I know.
clickbait.
It's clickbait, but
It's not, it's probably not in vogue,
well,
right? And most apps that I've seen, some of the language takes them to skill set.
Mhm.
So.
yeah, I think.
How much 20% time somebody puts in the morning.
Right. I think what's fueling, some of the renewed interest in Java is certainly around, native image and what that brings to the table, and the performance and everything that it brings. So
I think the 6-month cadence has really
Yeah,
changed everything.
it
too.
has.
Like, it just got stale.
it did get stale. Yeah.
And now it's just like, okay,
Yeah.
we've seen innovation every 6 months.
Yeah. Agreed completely.
There's a lot of misconceptions. I read articles or listen to podcasts and I'll hear someone say something like 10 years ago.
Yeah.
Things that they corrected.
Yeah, you hear people talk that haven't been around the language for a while, and yeah,
That was too verbose.
yeah, too verbose. Well, I mean, frankly, I left Oracle. I was with Sun, and Oracle acquired Sun, and I left a few years later, and was at Red Hat for almost 6 years. But what kind of intrigued me was, this whole thing about GraalVM, and when I learned that, we're kind of building out this team around GraalVM, like that's cool. I want to be part of that moving forward. So, I guess I kind of felt I've always been around, Java and the technology community for 20 years, but I kind of felt the same way. I thought, things were kind of but the 6-month cadence, some of the new technologies that are being introduced, I think it'll have a really profound impact on Java, and maybe get people to, not think of it as a language that's kind of seen its better days. So. Or at least for 2 more years till I retire. Any other questions? Okay, well, hopefully we gave you a good understanding kind of where the group sits, what we plan to do moving forward. Again, please don't hesitate to give us your input on the topics. We can rearrange, of course. If you're interested in speaking on any of these topics, let me know also. And then, we kind of gave you a level set into the language and kind of where we're at today. Of granted, it was a high level. We can get into details of any of those projects in future sessions. But the goal here tonight was just to kind of give you a taste of what's going on and help you understand that it's not a stale language anymore. And there's some really cool things happening in the industry. So thanks for coming out. Appreciate you being here in person. And hopefully we'll see you next month.